Mimikatz. In this section, we'll discuss how Mimikatz can be used to extract credentials from memory due to caching requirements of the Kerberos protocol. We'll also discuss local security authority protection and how it can be bypassed. Due to the automatic renewal of TGTs, password hashes are cached in the Local Security Authority Subsystem Service, or LSAS, memory space. If we gain access to these hashes, we could crack them to obtain the clear text password, or reuse them to perform various actions, which we'll discuss in a later module. Since LSAS is part of the operating system and runs as system, we need system or local administrator permissions to gain access to the hashes stored on a target. In addition, the data structures are not publicly documented, and they are encrypted with an LSAS stored key. Mimikatz is a powerful tool that we can use to extract and manipulate credentials, tokens, and privileges in Windows. In this section, we'll specifically use it to dump cached domain credentials and use it for other purposes later in this module. After launching Mimikatz from an elevated command prompt on our Windows 10 victim machine, we'll have to tamper with the memory of the LSAS process, which is normally not allowed since it belongs to the system user and not the current OffSec user. However, as administrator, the OffSec user can use SE debug privilege to read and modify a process under the ownership of a different user. To do this, we'll use the Mimikatz privilege debug command to enable the SE debug privilege by calling adjust token privileges. Once we have enabled the SE debug privilege, we'll dump all cached passwords and hashes from LSAS with Secker LSA logon passwords. The inner workings of the command are quite complex and beyond the scope of this module due to the inherent encryption and undocumented structures employed by LSAS, but the results show the NTLM hash of the OffSec domain user. Since 2012, when Mimikatz was released and cached credential dumping was popularized, Microsoft has developed mitigation techniques, LSA protection, and Windows Defender Credential Guard. In this module, we'll focus on LSA protection. As previously mentioned, Windows divides its processes into 4 distinct integrity levels. An additional mitigation level, Protected Processes Lite, PPL, was introduced from Windows 8 onwards, which can be layered on top of the current integrity level. In essence, this means that a process running at system integrity cannot access or modify the memory space of a process executing at system integrity with PPL enabled. To demonstrate this, we'll log into the Windows 2019 server AppServe01 as the admin user. This is done through the run as PPL dword value in HKey local machine system current control set control LSA with a value of 1. This protection mechanism is disabled by default due to third-party compatibility issues. On AppServe01, LSA protection has already been configured. When LSASS is executing as a protected process light, Mimikatz fails due to insufficient permissions. The secure LSA logon passwords command returns the access denied error value. PPL protection is controlled by a bit residing in the eProcess kernel object associated with the target process. If we could obtain code execution in kernel space, we could disable the LSA protection and dump the credentials. Luckily, this can be achieved with Mimikatz, since it comes bundled with the mimidrive.sys driver. We must be local administrator or system to dump the credentials, which means we will also have the seload driver privilege and the ability to load any signed drivers. Mimikatz can load the mimidrive.sys driver with the bang plus command. Once the driver is loaded, we can use it to disable the PPL protection for LSASS through the process protect command, while supplying the /process option to specify the name of the process, and the remove flag to disable PPL. While this technique will disable the LSA protection, it does require that we upload the mimidrive.sys driver to the victim machine, which may trigger antivirus. Next, we'll again attempt to dump the cached credentials. According to this output, we have bypassed LSA protection and have obtained the admin domain user's NTLM hash. In the next section, we'll discuss how to dump LSASS memory without Mimikatz.